Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashiru Mamboro. This lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. Today we'll be revising paper 2. We'll be giving you skills on how to answer questions, strategies, so that you are able to write and do well in your paper as you prepare yourselves. Now, with no wasting of time, I will just move so that we are able to move to our next slide, which I'll just check now before we start, so that we are able to move to the next one. Then we can take it from there. So as you know, paper 2, we're talking here of organic molecules. We're talking here organic molecules is divided into 3. So you are having your question 2, which is nomenclature, mainly is naming of organic molecules. So we'll be dealing with naming of these organic molecules. Then after that, we're going to look at physical properties. Remember, in physical science, we focus on 3 physical properties, which is your melting point, your boiling point, and your vapor pressure. So we'll focus on those and strategies to say how do you go about answering questions based on organic molecules. Remember, learners, we're talking about organic molecules, which has 58 marks here. So you have a lot of marks that you can get. If you can get 50 out of 58, already we're moving in the right direction. So ensure that you collect as many marks as possible under this topic, which is not a difficult topic of matter and materials, organic chemistry, with 58 marks. So after we've dealt with organic molecules, we're going to move to rates of reaction, which is part of chemical change. Remember, chemical change has 92 marks. So we'll be dealing with 92 marks under chemical change. So chemical change is start from rates of reaction, chemical equilibrium, then we are able to move from there. After chemical equilibrium, we'll look at acids and bases. Remember, learners, under acids and bases, we have a lot of definitions that you must know under acids and bases. And then you must be able to move after acids and bases. So we'll do electrochemistry, which is now your question on galvanic cell and electrolytic cell. And even there, we're expecting that you will collect a lot of marks. So we're hoping we'll give you good strategies that will help you and ensure that you are more confident to go and write paper 2. Now, if you remember the structure of the paper, we are saying we have section A, which is still 10 multiple choice questions with 20 marks. And then we are saying answer all your multiple choice questions. Ensure that when you are writing your paper, when you go to multiple choice questions, you answer every question. So we're saying from 1.1 to 1.10, ensure that you get you answer all those questions. Now, section B, which is our long questions or structured questions, we have 130 marks and the total is 150, and you'll be writing for 3 hours. So that is our standard, how the paper looks like. Now, what we're doing is our last push. So we're saying you must be able to interpret the data sheet. This is very much important as well. Data sheet is not for paper 1 only. Even paper 2, we're having our data sheet, we are saying be able to use. Remember, here we're going to be focusing mostly on calculating the number of moles. You will be calculating the concentration. And we are saying no different ways of calculating the number of moles. You have different formulas that you can use, know how to use all of them. But the most important thing we're saying, have data collection, because if you collect data, it will tell you which formula will be able to help you to answer the question. And we're saying copy the formula the way it appears on the data sheet. We're always emphasizing that we don't change formulas, you just copy it, you substitute on it, and we're able to move forward. And we're saying recognize and understand the meaning commonly used of action verbs. Remember, in physical science, we are saying define. And we have a lot of comprehension in this paper, which is paper 2. We are saying as you answer questions there, use bullet form. For example, when you are dealing with questions of physical properties, where we would like you to explain why the boiling point is higher or low, we are saying that answer in bullet form, because the bullets are independently marked. So you are not disadvantaged by writing in bullet form. But if you write in paragraph form, you are going to lose your marks there. So we're ensuring that you write in bullet form every point. You write it as a bullet. You will see as we do examples. You must be able to know how to respond to questions that require explanations and equations. And we are saying it is very much important here in physical science paper 2. For example, when you are writing pH, you can't write capital P. It must be that small p, and then you are able to write pH correctly. So just ensure that you are able to write these formulas the way they are supposed to, the way they appear on the data sheet. Is important. You can't change now a small letter, you make it a capital letter, because it changes the meaning of the formula. So please copy it the way it appears so that we don't lose marks. And if there is SI unit, indicate the SI unit, correct SI unit. Sometimes you'll be given cubic centimeters, which is your milliliters, and then you must be able to know that if possible you are dealing with concentration, it must be in mole per cubic decimeter. So those conventions are important so that you are using the correct SI unit. So I hope that will help you as we start with our lesson. Now, as I indicated, that we are going to deal with organic molecules, we're going to focus on nomenclature here, which the first thing under nomenclature, you will know that we have 9 homologous series. So that's where you start. You always know that in physical science grade 12, we have 9 homologous series, which is your alkanes, and your alkynes. I always refer to them as AAA so that you don't forget. It's alkanes, alkenes, and alkynes. So you got to know them, and then you must know that we have haloalkanes, we have aldehyde, we have ketones and esters, and we are having as well AC, which is your alcohol, and carboxylic acid. The importance of grouping these homologous series in this way, where we are saying AAA, H, A, and C, you are able to see that now you are able to differentiate. Even when it comes to the first 3, you know that these are hydrocarbons. So it simplifies it for you, because you know that I have AAA, which is our alkane, alkenes, and alkynes, are hydrocarbons. Remember, we have 2 types of hydrocarbons, which is your saturated and unsaturated. Saturated and unsaturated. So you got to know all these definitions. Definitions are important. So it's important for you to know what is homologous series. So we'll be talking to that in terms of question 2. You are able to do these definitions. You are able to define hydrocarbons, saturated and unsaturated hydrocarbons. You are able to differentiate amongst them and be able to identify whether it's saturated or unsaturated, which is important. Now, in the next question, we're expecting that you will have a question based on physical properties. As already I have indicated that we have 3 physical properties that we do in grade 12 for physical sciences, which is the melting point, vapor pressure, and the boiling point. I have a reason why I'm arranging them like that. And then I'm saying we have melting point, we have boiling vapor pressure, and boiling point. It's important that you know the definition of what is melting point, what is vapor pressure, what is boiling point. So I'm emphasizing here for you to always remember, because we don't want you to lose marks. When you're doing question 3, you're expecting that you will get a definition of melting point, vapor pressure, or boiling point. So we are saying, remember, as you define your melting point, you are saying here it's not a point. We emphasize that all the time, that melting point is not a point, but it's a temperature. It's a temperature at which the solid phase and the liquid phase are at equilibrium. So always remember that is an equilibrium at the melting point. So it's a temperature at which the solid phase and the liquid phase are at equilibrium. You write in full words so that you are able to get your 2 marks. So I hope the way I simplify that definition, you will be able to remember it and be able to know that melting point is not a point, but it's a temperature at which the solid phase and the liquid phase are at equilibrium. Now, when it comes to vapor pressure, hence I brought vapor pressure before boiling point. Vapor pressure is not a temperature, but it's a pressure exerted by vapor. It's a pressure exerted by vapor at equilibrium with its liquid. So that's how you will remember it. So, okay, vapor pressure is a pressure exerted by vapor at equilibrium with its liquid in a closed system. It's important because when you're having vapor pressure, it means now you are talking about the molecules have more energy. So if you don't close the system, they will the molecules or the particles will escape. Hence, we are saying it must be in a closed system. But you have seen when we defined melting point, we didn't say in a closed system because the molecules have very low energy. So the likelihood of the particles escaping is very low. So you got to understand it that way to say for melting point, we're saying the temperature at which the solid phase and the liquid phase are at equilibrium. For vapor pressure, we're saying pressure exerted by vapor at equilibrium with its liquid in a closed system. I'm emphasizing that if you take that closed system out, you will lose that 1 mark. So it's important. And then I want as well to emphasize the last definition under question 3, which is your boiling point. So we're saying boiling point as well is a temperature. The same way you define melting point, you will say even boiling point is a temperature, it's not a point. It's a temperature at which the vapor pressure, the pressure inside, is equals to the atmospheric pressure. Now, I want to emphasize something on definition of boiling point. If you say it's a temperature at which the atmospheric pressure is equals to the vapor pressure, we're going to mark you wrong, because remember when we starting to heat your substance, can be water. If you are boiling water at home, when you start, you are saying that the vapor pressure is not there, it's low. But as you start to heat the water, the pressure start to build inside the container. You will see the molecules, they will start to move. Hence, we are saying now the vapor pressure starts to increase. And when that vapor pressure is equal to the atmospheric pressure, we refer to that as boiling point. So we have emphasized. I'm hoping these 3, you have the 2 marks in your pocket to say I will be able to define melting point, vapor pressure, and boiling point. So you have seen that the first 2, which is melting point and vapor pressure, we're referring to equilibrium. And for vapor pressure, we say that equilibrium is in a closed system. So I've emphasized that. And then in question 4, we're going to focus on reactions of these organic molecules. Now, I want to say to you, remember that we talk about reactions like addition, elimination, and substitution. Substitution, addition, elimination. Remember, elimination, cracking is part of elimination. So it's when you eliminate that you're cracking the substance as well. So we're saying we have substitution, addition, and elimination as the reactions that you are going to do. So we are saying know these reactions. How will I identify a substitution, an addition, and elimination? We'll be focusing on the strategy to say how do you go about doing these reactions. So we're looking at that. We all also have a reaction that we refer to as oxidation. Oxidation, we use the name interchangeably with combustion. Sometimes we just refer to it as combustion, which is oxidation. Here we are having now our organic molecules that are reacting with oxygen, and we are using excess oxygen, so they are able to form carbon dioxide and water. So you are and water and energy is given off. So hence the reaction is exothermic. So you got to know that we have substitution, we have addition, we have elimination, we have oxidation. So at the end of this lesson, you must be able to know that under nomenclature, I know the 9 homologous series. I know these 9 homologous series, they differ from each other through their functional group. So it's important that you must know the functional group of each and every homologous series that we are going to talk about. So those are things that you must focus on as you prepare for yourself for these marks. As I indicated that we have 58 marks that are given under that topic. So then we're going to move to rates of reactions. Remember, the most important thing there is first the definition of the rate of reaction. You must know how to define the rate of reaction. Number 2, we are saying the most important thing is to know the factors that affect the rate of reaction and how they affect the rate of reaction. And you must know how to calculate the rate of reaction. So if you know that, and you know how the instruments that we use, for example, to collect the gas, for example, and then what do we use for all the instruments that we are using, the mass balance to check the mass and all that. So we'll look at that, and then we'll go to acids then bases. Very important topic of acids and bases. Remember, here we're focusing on Arena's theory and Laurie Bronsted, and then we'll look at conjugate acid base pairs, and then we'll look at the strength of this acid, because some acid we refer to them as strong acid, some are weak acid. From there we look at the bases, strong and weak bases. As well, we'll look at their Ka and Kb value. Ka and Kb value are very much important for you to have understanding of them. We'll look at the ionization constant of water, which is Kw, and then we'll look at titration under acids and bases as well, and then we'll be able to move. Now, after we have dealt with your titration, you must be able to use the CAVA, the titration formula, to do your calculation. Then we focus on pH. You must be able to calculate the pH of strong acids and strong base. When you are doing the calculations of this pH, it's important to check whether you are given a monoprotic acid or a diprotic acid, because if you are given a diprotic acid, there will be expectation that you must multiply the concentration that is given by 2. If you are given the concentration of a base as well, it's important to say, I'm given the concentration of the base, but on the formula of pH, I have H3O plus. So I must first find H3O plus. So we'll look at that so that you are armed and ready for dealing with the question of acids and bases. As well, the question of stoichiometric calculation is very much important. For all these questions, you must know how to do the stoichiometric calculation. And then our last topic, which is electrochemistry. We are saying we're going to focus on the galvanic cell. Remember, what is important here is your energy conversion. Remember, as you write paper 1, you were talking about generators and motors, where you were saying a generator converts mechanical energy to electrical energy, a motor convert electrical energy to mechanical energy. Don't make a mistake of still referring to mechanical energy in paper 2. In paper 2, remember, we're talking about a galvanic cell that converts chemical to electrical energy, and electrolytic cell that converts electrical energy to chemical energy. I hope we are moving together. I hope I have set the stage now. You see, this is what we want to achieve by the end of this lesson. You must be able to know the difference between galvanic cell and electrolytic cell, and how to calculate as well our EMF of the cell for galvanic cell. And then we'll focus on that. Then we will be able to close our session. I hope that we will move together. You are having a pen and a paper. You will take some notes. You will do some problems, and then you will be able to be well prepared for your paper as you go to write your exams. I've already indicated the topics and where to expect them. So we'll be following our topics in that fashion. As I have indicated, that we have organic molecules now, which is metal materials, is 58 marks. That is 38.7% of the paper. So we're saying if you study organic properly, you can be able to come with 30%, and then because you have 38.7, so you can pass paper 2 by doing very well in organic molecules. So it's important that you do everything, you leave no stone unturned there, and then you are able to be ready. When it comes to chemical change, we are saying this is lot of marks, which is there. That's your difference there. You will see that you are having more than 61% there that you are going to get from chemical change, which is talking here of 92 marks plus or minus. So it's very much important. And as I've indicated, that you will do the rates, will do chemical equilibrium, acids and bases, and electrochemical cells. I hope we are moving together. Now, the advice that I want to give you before we even start with the topics themselves is to say multiple choice questions are important, because this is 13% of our paper and they are taken from all these topics. You will see when you open your multiple choice, you will have 1.1, 1.2. The first questions there will be based on your organic molecule. So you will get multiple choice on all these topics that we are having. So we are saying all topics are examinable on the multiple choice questions, and we are saying each question consists of 2 marks. There are special consideration to be given in this question, and we are saying identify which topic the question belongs. You can't respond. You must first say, where is this question coming from? Is this organic molecules? If it's organic molecule, is it nomenclature? Is it physical properties? is the reaction, so that you are able to answer questions properly. So you must know where they belong and collect all the facts. And we're saying thoroughly analyze the question before attempting to choose the answer. And we're saying minimize the distractors. Remember, we give you 4 options. So we're saying no, remove 2 that are disturbing you there, remain with 2 options so that you have 50% chances of getting the answer correct. And we are emphasizing on this one. Do not skip any multiple choice question. Please don't leave a multiple choice question unanswered. The same with questions that needs you to calculate, because you know if you are supposed to calculate, you have a formula. Write a formula, substitute on that formula, because we'll give you for identifying a correct formula, we'll still give you that 1 mark. So it's important that all the multiple choice questions you will have entered A, B, C, or D. There must be something. You can't leave the exam room without answering any multiple choice question. I hope we are together and we are happy, all of us, that we're going to move to organic molecules. As I indicated, that the topic starts with like that. Now, the first thing that we want to remove on our way is the issue of definitions. Remember, I have defined for you at least some of them as we're studying, but it's important that you know all these definitions. You know these 2 marks of definitions you must know, and we're saying define according to exam guideline. Please do that and it will help you. The issue of homologous series, remember, we're saying these are series of organic molecules that are described by the same general formula. So they all have the same general formula. If you are saying, I belong to a family called alkanes, you are having the same general formula, which is CnH2n plus 2. So it's important to know that homologous series, they have the same general formula. They are described by the same general formula. If you have alkenes, it means we are removing the 2 because we're bringing a double bond. It means the general formula is CnH2n. If you belong to alkynes, now it will be CnH2n minus H2n minus 2, because we're removing further 2 hydrogens. Remember, when you bring a double bond, you remove 2 hydrogens. So when you bring a triple bond, it means 4 hydrogens have been removed. Hence, the formula will be CnH2n minus 2. So you must know all the 9 homologous series. You must know their general formulas. And I'm emphasizing that don't forget for haloalkanes. Haloalkanes, we said it will be CnH2n plus 1x, because that X stands for the halogens. In this case, you are having that in that group bromine and chlorine. Those are the common ones that we use. But if you find fluorine and iodine, still is fine. That X stands for those group 17 elements that we are having there. So you are able to know that these are haloalkanes is CnH2n plus 1x, because we have replaced a hydrogen with the halogen. So you are able to write the general formula. The same for aldehyde, you know, is CnH2nO, because we have a C double bond O there. So hence we remove 2 hydrogens, we put an O there. And then for ketones, it's the same, CnH2nO. That's why ketones and aldehydes are functional isomers, because you can see they do have the same general formula. So we'll talk about that when we talk about the isomers as well. And then you have your esters, and then your esters is CnH2nO2. You see, there are only 2 homologous series out of the 9 that have 2 oxygen. It's an ester and a carboxylic acid. Hence, we are going to say the last 2 is alcohol and carboxylic acid. And you know your alcohols, they are having now CnH2n plus 1 OH, because we are removing 1 hydrogen, replacing it with the OH to get an alcohol. Hence, we have CnH2n plus 1 OH. So I hope this will help you as you do your revision. Remember, same general formula for esters and the carboxylic acid, which is CnH2nO2. So I'm emphasizing that it is your responsibility to know all 9 homologous series. You know their general formula, because you will definitely collect marks as and when you answer questions. I hope I was able to help you to remember that how to define homologous series. We said this is a series of organic molecules that are described by the same general formula. So you can't just say same general formula. You must write it as it appears in the exam guideline. Functional group, this one was saying these are bonds, these are atoms, and group of atoms. Exam guideline is saying the atom is the group of atoms that determine the physical, which is question 3, your physical, and chemical, which is question 4. So it's the atoms, group of atoms that determines the physical and chemical properties of organic molecules. Please know these definitions as they appear here. Hydrocarbons, we're saying these ones, they are made up of hydrogen and carbon only. The most important thing is that you must say they are made up of hydrogen and carbons only. So you must say only, because if you don't say only, your definition will be wrong. Saturated, we are saying saturated, we are saying they have no multiple bonds, between carbon atoms. And unsaturated, they have multiple bonds between carbon atoms. So I'm emphasizing know all the definition so that you are able to move with no problem. And we are saying when it comes to isomers, remember we are referring to them as structural isomers, because these structural isomers, they have the same molecular formula. So that as long as you see an isomer, same, they have what is same? Molecular formula. As long as it's an isomer, you would say they have the same molecular formula. Different, what is different is on the name. If we say structural isomer, you will say same molecular formula but different structural formula. If we say chain isomer, because we do chain isomer, we do positional isomers, not position but positional isomer, we do functional isomer. So for chain isomer, we are saying they have the same molecular formula but different types of chain. So they have the different type of chain. And the positional isomers, we're saying they have the same molecular formula but different position. Position of what? Of the substituent, of the side chain, and of the functional group. I say SSF so that you don't forget. It has the same molecular formula but different position. For this one, for positional isomer, it has the same molecular formula but different position of the side chain, of the substituent, or the functional group. So there are 3 things that we can write there that is at a different position. And for functional isomers, we're saying they have the same molecular formula but different functional group. And then we've summarized these functional isomers as cake, to say it is carboxylic acid and ester. Because why? Because they have 2 oxygens. We have agreed all of them is CnH2nO2. So these are functional isomer because they have different functional groups, but they have the same molecular formula. So we say functional isomers is carboxylic acid and esters. It's aldehydes and ketones. Please capitalize on that and get those marks. The issue, hence I've indicated aldehydes and ketones and carboxylic acids and esters. And we said this is CnH2nO, but these others are CnH2nO2. These 2 are functional isomer, and aldehydes and ketones are functional isomer. I hope you are happy with the isomers and you will be able to identify them, that they must be able to do that. And if you check your chain isomers, they will be belonging to the same homologous series. But when it comes to functional isomer, they belong to different homologous series because they have different functional groups. Now, functional groups, you have this table. Remember always the functional group, that which makes it different. I always want to put it this way, to say your functional group is what makes it different from alkanes. What makes this different from alkanes? That is your functional group. For example, I will look at alkenes. For example, what makes it different is the carbon-carbon double bond, and that is our functional group. And when we say draw the structure or structural formula of the functional group, remember carbon must always have 4 bonds around it. So you can't write carbon-carbon double bond like that as your functional group for alkenes. It will be wrong because the carbon must have 4 bonds at all time. For alkynes, You can't write it like that. There must be 4 bonds around the carbon all the time, because sometimes we'll ask you to write down the structural formula of the functional group. So always understand the question. And then for our haloalkanes, we are writing carbon with an X there. Don't forget, carbon must have 4 bonds around it. So that's how you go about writing them. For alcohols, the same. You'll have a carbon with 4 bonds around it. Then you indicate the OH. And some of these functional groups, they have names. They have been given names. For example, for the alcohol OH there, we're calling it is the hydroxyl group. So you will refer to it as such. So we can ask you, what is the name of the functional group of alcohol? You must know it's called hydroxyl group. And then you have, and now for aldehydes is carbon, C double bond O and an H, and that is called formyl or formyl group. Formyl group is for aldehydes. And for ketones, we are saying this is called now, it has a name, and we are saying this is a carbonyl group. And then you are having here carboxyl group for carboxylic acid. And then you are having there your ester that is given. So please ensure that you know the functional group, the structural formula of the functional group, and the name of the functional group. If you have checked, we have named about 4 of them, which is your carboxyl for carboxylic acid, your carbonyl for ketones, and your formyl for aldehydes, your hydroxyl for alcohol. So please don't forget those 4 names. They are important that you remember the names of the functional group. Now let's look at an activity, because we want to be more question based, because we are preparing you. So we're saying, which one of the following general formula of alkanes? So you see the question comes, those general formulas are important. Remember, alkanes, they have a maximum number of hydrogens. So definitely, because we are moving, we'll be able to say C is your correct general formula for alkanes. So you can't go and write exam without knowing the general formulas. Now consider the following statement regarding the compounds in the same homologous series. So remember, by definition, what is homologous series? We said homologous series, this is a series of organic molecules that can be described by the same general formula. So if you have same general formula, you have same functional group. Hence, we are saying they don't have same boiling point. They don't have same molecular formula, but they have the same general formula, which means they have the same functional group. So you are able to see that number 2 is your good answer there. So I'm going through that. Remember, on the strategy I indicated that you will go through all these options and remove the distractors, so that you are able to get answer. And I want us to do all the questions that you are going to write. I want us to be able to go through them during this lesson. Now we're saying name of the functional group. So you see the importance of knowing the names of the functional group of alcohol. So you got to know that carboxyl group is for carboxylic acids. Carbonyl is for ketones. Formyl is for aldehydes. Hydroxyl is for alcohol. So you know that you have hydroxyl there. You got the 2 marks. Remember, these questions are coming from previous question papers. Hence, we are saying do this and do it, and you will be able to enjoy yourself. Now, which one of the following compound is an aldehyde? We're talking to the issue of suffix, how the name end. Remember, for aldehydes, the name will end with an al there. Suffix, the suffix, how the name end. So for aldehydes, it ends with the al. So you will know that pentanal is for aldehydes. So you know that the homologous series gives us the suffix. Then you are able to get your 2 marks to say aldehydes is pentanal. You see, these are marks that we are expecting you to collect. Hence, we are saying you have 58 marks to collect under organic molecules, and you can come back with as many marks as you can. Which one of the following compounds is a carboxylic acid? Which one is a carboxylic acid? You know carboxylic acid. How do you see them? Cu. Their name must end with a cu there. The C double bond OH. So you know that C double bond OH, which you can write it like that. C double bond OH is for carboxylic acid. So you're just looking for your cu for carboxylic acid, but it's important that you go through all the other options, because you are having this option as well now, which you can see now is a C double bond O. So that's a ketone. We're having a ketone there. When you have the CHO at the end, don't forget it's an aldehyde. When we're having now, when you're having CoO at the end, that is your carboxylic acid, and the question was looking for carboxylic acid. When you have the OH there, it's an alcohol. Remember, we can change the question and say, what are the name of these functional groups that are found here? Remember, we said this is a carbonyl for ketones. For aldehyde, it's a formyl group. For carboxylic acid, it's a carboxyl group. And then for alcohols, is the hydroxyl group. So you're able to do that and enjoy your activity, and you get your 2 marks for saying carboxylic acid is a C double bond O OH. So you get your 2 marks there. Now, let's look at isomers now to say which one of the following pairs of compounds are functional isomers. Remember, we said functional isomers have the same molecular formula but different functional group. So if we check, this is an alcohol. This is an alcohol because of the ol. This is an aldehyde. The suffix there tells you the homologous series. Now this is an ane, is an alkane, and this is an ane, is an alkane. So they cannot be functional isomers because their functional group is the same. Now you are having propan 1-ol and propan 2-ol. Then you are having propanoic acid and methyl ethanoate. Now, before you answer the question, it's important to check that, okay, butane and 2-methyl propane, those are chain isomers. Remember, they will have C4H10. They will have the same molecular formula but different types of chain, because this is a branch chain, this is a straight chain. So you are able to say, okay, even though the question they didn't ask me this question, as you are studying, you are preparing yourself for your exams, you are able to look at that and say, okay, the question is looking for functional isomers, but are there any other isomers that I can see here, so that you are able to revise all the isomers. So you are able to see that, oh, this one was a chain isomer, and then propan 1-ol and propan 2-ol. You are able to see, okay, here what is changing is the position, of the OH of the functional group. Hence, the OH is in carbon number 1, the OH is in carbon number 2. So this must be positional isomers, because we said positional isomers, they have the same molecular formula but different position of the substituent, of the side chain, or the functional group. So the functional group here have different position. So you're able to see this is positional isomer. And then when you look at this, you are using propanoic acid. Remember the acid, we said they have the same general formula, which is CnH2nO2, which is the same as the general formula for esters, which is CnH2nO2 as well. So you know these are same molecular formula but different functional group. They are referred to as functional isomers. So you are able to do that. You see this slide now, it revises with you all the isomers that you were expecting to know for the purpose of this exam. I hope this helps you and increases your confidence when you deal with question. Let's look at the issue of esterification. To say now, as you deal with esters, you must be able to say, as you deal with esters, this is an ester. Remember, how do you know that this is an ester? You know it because esters and carboxylic acid, they have CnH2nO2. That one you know for a fact that as long as there are 2 oxygens, it's either an ester or carboxylic acid. As you go to the exam, you have that in mind. 2 oxygen, ester or carboxylic acid. So immediately you see 2 oxygen there within the structure. If it's within the structure like that, it's an ester. But if it's COOH at the beginning, carbon number 1, we refer to that as a carboxylic acid. So this will be an ester. Now, the question is saying which one of the following pairs of reactants. Now they're saying to prepare this one, this ester, which reactants did we use? That's what this question is saying. You're saying which one of the following pairs of reactants can be used to prepare this compound in the laboratory. Now let's look at option number A. It's saying propanoic acid. Remember, prop is 3 carbons. So The acid is the one that has a C double bond O and an O there. This one is a C double bond O, is your acid. But you can see that the one with the C double bond O has 2 carbons. It cannot be propanoic with 2 carbons. So this must be wrong option. Let's look at option number 2. It's saying propanoic acid again. As long as we're saying this is prop, we are wrong because there are 2 carbons. It cannot be propanoic acid. It is out. Let's look at option number C now. We're saying ethanoic acid. Ethanoic acid has how many carbons? 2. 1, 2. So this is correct. It's from ethanoic acid. Let's look now at the alcohol. Propan-1-ol, which is a primary alcohol. It's important that we use primary alcohols. So it's a primary alcohol. Then you are able to see that, okay, this one is propan-1-ol. 1, 2, 3. Propan-1-ol, correct. So you are able to choose your answer as number C, and you are able to get your marks. So I hope that helps you as you move and know. Maybe the other thing that I can emphasize under esterification, remember you are having ethanoic acid and propanol in the presence of a catalyst, which is your sulfuric acid. Remember the catalyst for this reaction is H2SO4, which is sulfuric acid. And we are saying as well, water is one of the products. So sometimes we'll ask you to show the whole reaction. So you must be able to draw ethanoic acid, structural formula, propan-1-ol, structural formula, and give our product, which is now this one, which is now propyl ethanoate, because we'll want you to name it as well, to name the structure, and I'll be doing naming in the next activity. Now, the issue of empirical formula is of paramount importance when you're dealing with paper 2. So it's important to check to say which one of the following is the empirical formula of 1,2 dichloroethane. So it becomes even much easier when you write 1,2 dichloroethane. So you have 2 carbons, and then you have ethanes, which is your ethane there. This is our ethane with 1,2 dichloroethane. So you're able to draw it like that. And then when we say now, we are saying the molecular formula of this is C2H4Cl2. Remember, we want the simplest form of this. So can I divide this by 2? Yes, I can divide by 2. I will get, what will I get? I will get a C. If I divide 4 by 2, I'll get CH2. If I divide Cl2 by 2, I'll get Cl. So you can see that the right one must be CH2Cl, which is now number B as the empirical formula, because you wanted the simplest ratio that you can get. So you can't get 1,5, for example. It must be the simplest whole number that you are getting for your empirical formula. So it's important that you know the issue of empirical formula. Now, I want to focus now on naming and ensure that you are able to name, because it's important that in question 2 or in nomenclature you understand it very well, because all the other questions, question 3 and 4, which is your physical properties and your reactions, they will depend on your knowledge of the molecules themselves. If you know everything that you are supposed to know under this question 2, you will do very well even in the other questions 3 and question 4. Now let's look at this one. How do you name? I just simplified here to say look at 3 things. Let's look at 3 things and name the structures without wasting time. So what we are saying here is that the first thing that you would look at is the suffix. How do you get the suffix? You look at the type of functional group or homologous series. For example, when you get a structure, you will check, is it an alkane, alkene, alkyne, alcohol, aldehyde, ketone, carboxylic acid, or ester. So immediately when you get that, it will tell you how the name will end. So you start with that. If it's an alkane, you say it's an ane. From there, for the parent, you're going to look at the number of carbon in the longest carbon chain. So you have to identify the longest carbon chain and check the number of carbons in that longest carbon chain and be able to say, okay, we have 6 carbons, so it's hex. So you'll say, okay, if we have 6 carbon, it will be hex. We'll be naming right now. And then you must look for substituents. Our substituents in this case is your halogens, which I said is bromo, chloro, most of the time, almost always, but we can still have fluoro or iodo, because we had a situation where we had those in our papers. So it's important that you know that those group 17 halogens, they are our substituents. And then we say the structure will become a haloalkane when it has that. For esters, as you have seen, we use those substituent. We call them the substituent or side chains. So these substituents, methyl and ethyl. So all of these, bromo, chloro, methyl and ethyl, they all have the same preference. I want you to understand me here. They all have the same preference, means that we prefer all of them. The only thing that if they are in the same carbon, we will do what is called alphabetical preference. So you don't look at a bromo as a functional group because it will confuse you. Look at it as a substituent which has the same preference as your methyl and ethyl. I hope you got that. So this will always be prefix. So it means bromo. If there is a bromo in a structure, the name will always start with that. So if you are having bromo, let's say in carbon number 2, you will say 2-bromo. You see, the prefix, the substituent must have the number. In which carbon do we find that substituent? So the name will be 2-bromo hexane. So I hope this helps you. And then as we are moving now, we're going to do examples of naming. Then you will be able to understand. Let's look at this question. It says, consider the following structure. Now we're having our structure here. Which one of the following is the IUPAC name of this compound? So what I will suggest, name the structure, then go to the options that are given so that you don't go and guess the answer. So how do you go about naming the structure? Remember what I said. I said we'll look at the prefix, which is the substituent. We'll look at the parent, which in this case is how many carbon in the longest carbon chain. And the last thing, we'll look at the suffix. Our suffix, we are saying functional group, homologous series. Which homologous series? How the name will end. Let's start now. I always advise you to start from the end going backward when you're doing your naming. To say, okay, in carbon number 1, we are having C double bond OH. Remember, when you're numbering, you are numbering from the closest to the functional group. You can't say carbon number 1 is this side. No, carbon number 1 must be the one that is a functional group. Now that is carbon number 1. Carbon number 2, carbon number 3, you have an option. You can go to the left or to the right to say, okay, this is carbon number 4. So we have 4 carbons. You remember, the first thing you are saying suffix. Which functional group do we have here? We have a Cu. Remember I said a functional group is that one when you remove from the structure, it becomes an alkane. So you can see that if we were to remove that, we'll have an alkyl group. So it's important that this Cu is for carboxylic acid. So you know that carboxylic acid, their name ends with oic acid. So I'm going to say this name will end with the oic acid suffix because it's a carboxylic acid. Parent, I'm saying how many carbons do you have in the longest carbon chain? So you're able to say 1, 2, 3, 4. Then you're able to say, oh, 4 is butan. It's important to have this understanding. I want to emphasize it here. Remember, we're saying 4 carbons is but. You can't say but here. You say butan. So this thing of using meth, eth, prop, but, pent, hex, hept, and oct, they work for your first 4 homologous series, which is your alkanes, alkenes, alkynes, and haloalkanes. But the last 4 homologous series, you don't write but, you write butan. You only remove the E from the how you will name the alkanes. So you will say butanoic acid. You can't say butoic acid. I'm telling you, we'll take that 1 mark away from you because it's not butoic acid, it's butanoic acid. So you write butan, you only remove the E from butane. Then you say butanoic acid. We do this for our last 4, which you will remember. I said if you said AAA, Hague, AC, you will be able to say, okay, from aldehyde, ketones, esters, and carboxylic acid, we're going to write the whole name without an E. Then you are able to add the suffix. I hope that helps you as you deal with this matter. So this is butanoic acid. And I'm saying if you say butoic acid, we will penalize you a mark for that. Prefix, do you have any substituent? Yes. In which carbon do we find those substituent? Remember I said you must always number your substituent. In carbon number 2, we have a methyl. Carbon number 2, we have a methyl. And carbon number 3, we have another methyl. So which means is 2, comma 2 because there are 2 of them there, comma 3. And then when you between the number and the letter, you put the hyphen. We emphasizing that, and that will give you trimethyl. Tri because there are 3. Trimethyl butanoic acid, and it's one name. Remember, learners, all the 7 homologous series, with the exception of esters and carboxylic acid, all of them we write one name. It's only for esters and carboxylic acid where you will have methyl propanoid. For example, you will have butanoic acid as 2 different names, but this one you will write it as one name. You don't separate, there's no space between them. You just write the name, the same one, and then you are able to come here to the options and say, oh, it's 2,2,3 dimethyl butanoic acid as one name there, you see. Then you are able to get your 2 marks. I hope this has helped you as far as naming is concerned. Time willingly, I will have gone through many naming opportunities, but I hope this has helped you to understand how do you go about naming. Maybe I will do naming of number A, for example. So I'm saying, as we consolidate question 2 and finish it now, we are saying there you are given structure number A. We are saying that A, which one is carbon number 1? How will I know, say, which one is carbon number 1? This one is saying I'm carbon number 1. Even this one is saying the same thing. I'm carbon number 1, because it's either we number from the left or from the right. How do I make a decision to say where do I name from? So now this one is saying I'm carbon number 2. Even this one is competing, is saying I am carbon number 2. But if we check in carbon number 2 from the left, we have a methyl. In carbon number 2 from the right, we have a halogen. So which one will win this competition? Because all of them, they're competing to be carbon number 2. What we do, we go to carbon number 3, because remember what I said, bromo and methyl, they are all called substituents and they have the same preference. Please understand this one before you go and write your paper 2. To say bromo and methyl have the same preference in terms of the halogens and the side chains, methyl and ethyl. Now, if we go to carbon number 3 here, we get another substituent in carbon number 3. But if we go to carbon number 3 from the right, there is no other substituent. Therefore, I'm going to number from the left, because from the left we are having the most substituted site. So carbon number 1 is this one, number 2, number 3, number 4, number 5, number 6. I have included this so that we remove the misconception that bromo will always come before methyl. No. If there was no CH3 in carbon number 3, bromo was going to be preferred because of alphabetical preference, but not that bromo has preference over methyl. They have the same preference. I hope I have explained that nicely. You have understood. So this is now when we name, remember what we said. We said we always start with our suffix, the name. How will the name end? Okay, do we have any functional group here? Nothing. Remember, we're dealing with the haloalkane. This is a haloalkane. And if I write a haloalkane here, you will be able to see that, oh, haloalkane, they end with ane, same way as alkanes. So this is an ane. This is an ane. The number of carbons in the longest carbon chain, we said there are 6. So this is an hex. So it's a hex. That is, the parent is hex. The suffix is ane. How many substituents do we have? Substituents? Yes. Where do we find them? In carbon number 2 and carbon number 3, we have dimethyl. Carbon number 2 and carbon number 3, we have dimethyl. Don't forget the issue of the comma and the issue of the hyphen. 2 numbers, they're separated by the comma, a number and a letter by a hyphen. So 2,3 dimethyl, that's what you are having there. And then you are saying, okay, we have another substituent in carbon number 5, that is 5-bromo. Now, this is the only time that bromo now, we're going to prefer it now when we write the name. We are going to use alphabetical preference. But when we are numbering, we don't use, we first look at how the substituents are in the structure. So the name of the structure, you will have seen that it will be 5-bromo, 2,3 dimethyl, Hexane, and it must be one name like that. I hope I've helped you in terms of naming. And as you answer this question too, ensure if you're given a molecular formula like that, draw that structure so that you are able to see it and name it wisely. And then you are given there already, when you see the two oxygens, you know it's either an ester or a carboxylic acid. So you will see that the two oxygens are within the structure. So that must be an ester. When you see an O, you know it's a ketone because of that suffix, and the C double bond O is in carbon number 2. So it's very much important that you have that understanding. I hope this has helped you and you are happy for question 2 as we move. Now, time willing, we're going to say physical properties. Remember, I've defined for you the 3 physical properties already, which is your melting point, boiling point, and vapor pressure. Now, we are going to say, now this melting point, boiling point, and vapor pressure, this is what we refer to as our dependent variables. That's what we are measuring in this question. We are measuring the melting point, the boiling point, and the vapor pressure. Now, what are the independent variables? What are we changing during this question? I always refer to them. It depends on these 3. They are dependent variables. They depend on the intermolecular force. They depend on the functional group. They depend on the branch. Is there a branch? And then is there molecular mass? Can depend on the molecular mass and can differ. So this what this will depend on. If I'm to write it correctly, I'll say if chain mob, so that you don't forget. So you see that we look at the intermolecular force, we look at the functional group, we look at the chain length, we look at the molecular mass, and we look at the branch. So that's what we look for, to say, okay, the melting point will depend on the intermolecular force. What type of intermolecular force do we have? It will depend on the functional group. It will depend on the chain length. Remember, as the chain length increases, we're expecting that the melting point and boiling point will increase, but the vapor pressure will decrease. As I've indicated on the slide here, to say as long as you have lower strength of the intermolecular force decrease, we're going to have lower boiling point and lower melting point, but higher vapor pressure. Remember, the vapor pressure is always not the same as boiling point and melting point. The same there, you are able to respond like that. So I hope that helps you as you prepare yourself. We have already indicated. Remember, when I said we are having triple A, A, and C. So they are triple A, these ones. We're saying, okay, these ones, they have London forces and they are hydrocarbons and they have weaker intermolecular forces. You see, so you're able to know that the weaker intermolecular forces, we find them here on these London forces. Weaker intermolecular force, you must write intermolecular force in full. And then Hague, they have London force and dipole. So you know that these have dipole because you don't have to lose marks of just identifying the type of intermolecular force that we get. So if you have alcohol and carboxylic acid, we said these ones, they have alcohol have one side of hydrogen bond and the carboxylic acid has 2 sides of hydrogen bond. So I hope you see that. And then in terms of strength, this is weaker, and then this is dipole is stronger than London but weaker than hydrogen bond. One side, obviously, these are having hydrogen bond, but one side, it cannot be stronger than 2 sides. So carboxylic acid have the highest strength of intermolecular force as compared to alcohols, which have one side. So it means alcohol, they form one hydrogen bond as compared to carboxylic acid that will form 2. So carboxylic acid are the strongest intermolecular forces that we find there. The strongest intermolecular forces, which we call hydrogen bond, are found in the carboxylic acid as compared to alcohols, because alcohol will have one side of hydrogen bond, carboxylic acid has 2 sides. I hope you enjoy that and it makes you ready and say, I'm willing to do this. Now, when you get questions, you will get your questions in a graph form. So you will get a graph like that. Don't be confused. Look at the graph, analyze the graph, be able to answer. Remember, we told you already that which one is the independent. I told you that the dependent variable are your 3 physical properties, which means this one, You can see that dependent on the y-axis, the boiling point. In this case, our dependent variable is the boiling point, and what is the independent? What are we changing? We're changing the number of carbons. Remember, I said according to the exam guideline is the intermolecular force, the functional group, the chain length, the molecular mass, and the branch. So what are we changing here? The chain length, which is the number of carbons. As the chain length increases, the boiling point increases, and you can see on the relationship there, as we move to the number of carbons increases, all the boiling points of the A, B, and C are increasing. Then you can see that as the chain length increases, indeed the boiling point increases, which means more energy is required to overcome the intermolecular force. I will come to how you answer questions very quickly. I just want you to be able now to identify the dependent and independent variables for each question. Look at this one. We're given hydrocarbons A, B, and C, and we're given their vapor pressure. Remember, vapor pressure is our dependent variable. It's important that when you get a question, you're able to say dependent variables. I know them. There are three: melting point, vapor pressure, and your boiling point. Now, we're having our A there, which is how many carbons? 1, 2, 3, 4, 5. 5 carbons pent. So it's a pentane. We're having pentane with 5 carbons. But now you can see we have one branch here. We have 2 branches here. Okay, so you are able to see, because we'll ask you what is the independent variable. What are we changing? So you are able to come and say, okay, what are we changing here? Oh, we're changing. Oh, we're increasing the number of branches. We're increasing the number of branches. 0 branch, 1 branch, 2 branches. Some will talk about the surface area. It's still fine. So we're saying now, as you can see now, as the number of branch increase, because we'll say what is the trend of the vapor pressure here. As the number of branch increase, you can see that the vapor pressure is increasing. Remember, when vapor pressure increase, it means melting point and boiling point are decreasing. So what does it mean? You know that as we decrease the strength, vapor pressure must increase. So you see that, okay, as the number of branch increase, the strength of intermolecular force decreases, which means less energy will be required for C compared to B. I find it very important as you're answering questions that if you are given ABC, just respond in terms of ABC instead of going through the trouble of naming the structure, of saying pentane, because you can make mistake. But just talk about A, B, and C as you compare them, and you will be able to get your questions there. Then you are able to see that, okay, what is the dependent? It's vapor pressure. What is the independent? We said what is changing is the number of branches. Some will say it's the surface area. As the surface area decreases, the vapor pressure is increasing. So you are able to see all these things, and you are able to answer all these questions, and you are enjoying yourself, I hope. What is remaining the same? What are we controlling? What is the same here? They belong to the same homologous series. Don't make a mistake of thinking that our independent variable is hydrocarbon. No, it couldn't be hydrocarbon. Remember, I indicate to you to say exam guideline is saying our independent variable is the intermolecular force, is the functional group, is the chain length, is the molecular mass, and branch. Please refer to those. They will help you as you do these questions and enjoy yourself. Now, let me move so that we are able to do that. How do you go about answering the question? This is very much important. We are saying, as you answer the question, there are 3 things that we're expecting from you. Number 1, step number 1, bullet number 1, you answer question in bullet form. I'm emphasizing that so that we don't have problems. So we're saying, state the difference in structure. As already I've told you about the if chain mob there. If chain mob. What is different in the structure? What is different? That is your independent variable. Identify your independent variable. If it is the branch, you say, okay, what is changing? What is different is the branch. What is changing is the molar mass. What is changing is the chain length. What is changing is the intermolecular force. So check what is different. Bullet number 1, you will tell us that there is increasing chain length. The chain length increases from A to C. In the case that we're talking about the previous slide, where the branches were increasing from A to C. And as the branch increase, now bullet number 2, what is the effect of the increasing in the branches on the strength of intermolecular force? So you are able to say as the number of branches increases, the strength of intermolecular force decreases, which is bullet number 2. Bullet number 3, tell us about energy. Hence, we are saying here, ice, which is now you refer to an independent variable to say is the chain length, that is the branch that are increasing from A to C, and then you are saying you are comparing the strength of intermolecular force to say as the branches increase, the strength of intermolecular force decrease. How much energy? If the strength decrease, it tells you less strength, less energy is required to overcome the intermolecular force. Please, learners, don't say less energy is required to break the bonds. No, we are saying less energy is required to overcome the intermolecular forces. I hope I was able to take you through and you are happy with this question, and you'll be able to do it. Now, which of the following compounds will have the lowest boiling point? Already you know that alkanes, we said, oh, these ones they have London force, these ones we said they have dipole, these ones they have hydrogen bond. Methyl propane is still under alkanes, so it has London force. You know the lowest is London force. But now look between A and D. They all have London forces. They are the lowest, we agree. But which one has another issue on top of that? You can see that D is branched. So as you're having branched, the strength decreases, which means D is our correct answer. And you are able to apply that and get your marks and enjoy yourselves. Now, look at this, the relationship between two boiling point, and is that graph that I was talking about when I started. It says atoms, we are having an alkane, we are having an alcohol, and then aldehydes. And you know, we're having now the boiling point between these three. Alkane will be the one with the lowest boiling point. So alkane is the lowest because they have London force. Aldehyde, they have London force and dipole. So there must be number 2. You're able to say this must be aldehyde. And then you are able to say alcohols, they have the highest strength of intermolecular force, hydrogen bonds. Remember, alcohols, they have London forces, they have dipole, they have hydrogen bond. But we only refer to the highest intermolecular force, which is hydrogen bond. So you are able here to say A is an alcohol, primary alcohol, because it has the highest strength of intermolecular force, it has the highest boiling point. The question is, which one of these is curve B? Immediately, because you have done that, you have named, you have already allocated them there, you are able to know that it's an aldehyde, and then you get your answer and you are able to enjoy yourself. Now, this equation, I'll just take you through in terms of the strategy to see how do you respond to this type of questions. Define the term boiling point. You must be able to define the boiling point. Remember, we said it's not a point, it's a temperature at which the vapor pressure is equal to atmospheric pressure. You must write it in full. And I indicated if you say atmospheric pressure is equal to vapor pressure, you will get it wrong. So please be careful to write it correctly. What is the relationship between strength of intermolecular force and boiling point? Is that as the strength of intermolecular force increase, the boiling point increase. Please, learners, you can't use directly proportional. This is not paper 1. You would say as the boiling point increase, as the strength of intermolecular force increase, the boiling point will increase, not the other way around. Now you are given a table there. You see your dependent variable as we talked about when we started, and you are given there your different homologous series there. You can see what we are changing there. We are changing the functional group there. By changing the functional group, and then you can see we have London force. This one is dipole. Propanol, it will have now hydrogen bond, but we said it has one side. And propanoic acid, it will have hydrogen bond, but with 2 sides. Hence, you will see that the boiling point is the highest for propanoic acid because it has the highest intermolecular force. What is the important here? Analyze the table so that before you answer the question, you know what is happening on the table. Refer to the type and strength of molecular force. So this question is telling you straight that the first thing you will tell us about is the type of intermolecular force, and then you will tell us about the strength of intermolecular force, and lastly you will talk to the energy that is there. So between compound A and B, what is the type? You are saying A, what is the type? It has London force. B has dipole. B has dipole. A has London force. Now you are able now strength. Which one is stronger? You can talk about B. You can say B has stronger intermolecular force than A. You are comparing. Remember, B has stronger intermolecular force. That is bullet number 2. B has stronger intermolecular force than A. So more energy will be required to overcome intermolecular forces in B than in A. You see, it's important you are using the letters there. Instead of writing proper noun and all that, it becomes long. You might make mistakes. Refer to them as A and B as the question did. Compound C and D, you will say all of them, they have hydrogen bond. That is your first mark. But the alcohol has one side of hydrogen bond. The carboxylic acid has two sides. So you're able to say, okay, D has two sides of hydrogen bonds. So D is there, has stronger intermolecular forces than C. And you will say more energy. As long as you have strong intermolecular forces, more energy will be required to overcome intermolecular forces in D. So you're able to do that. Just look at that. You are having 3 marks again there in bullet form. Is compound B a gas or liquid at room temperature? So you just go to B is 56. How much is room temperature? If you don't know room temperature, you are doomed. Remember, standard temperature when you do your galvanic cells is 25 degrees Celsius. That's your room temperature. So 25 degrees Celsius, obviously it hasn't boiled, so it's not a gas. It can only be a gas after 56. Remember, it boils at 56, so you're expecting that it must be liquid, and you are able to get your 10 marks. I hope that helps you as you deal with organic molecules and you move forward. Now let's go question 4, which is now your reactions. Now we are saying reactions of organic molecules. Please learn us this strategy. As you can see from our internal moderators report, we are saying USA, not a country. We are saying when you are having an unsaturated hydrocarbon becoming saturated, the reaction is called addition. So when you are having a double bond becoming a single bond, the reaction is called addition. So you just look at that to say, do we have a double bond? Yes. Is it becoming a single bond? Yes. That is addition. USA. Unsaturated becoming saturated is addition. Please, let's not lose marks there. Let's collect maximum marks on this question. Now, when you are having saturated becoming unsaturated, when you're having a single bonds, a structure with single bonds only, now becoming single bonds between carbon atoms, now becoming double bond, you know that, okay, we are moving from saturated to unsaturated. The reaction must be elimination. So we are together. When we are having saturated, remaining saturated, we say substitution. So when you have a saturated single bonds between carbon atoms and another single bonds between carbon atoms in the structure, there is no change in terms of the bonds. They are all remaining single. So it's saturated, remaining saturated, we call it substitution. So that's what we're expecting from you, and you'll be able to identify these reactions. Learners, please be able to do that. Now you can see that in our exams, like we had in 2021, we had an issue where learners were given a question of synthesis like that one, and learners were unable to go through that question, and it was not right. So I wanted to quickly go through it as we move. We're having but2in, which is a unsaturated. Obviously, unsaturated, it undergoes addition. We know it means this one is saturated. So if you have butene, now it's becoming saturated. It means the reaction step 1 there is addition, USA. You see how you go about it. Then you are having a saturated, but it's forming 2 products. So you see, this must be elimination, which means that this must be unsaturated. Remember, we're having 4 carbons. Now we're having 3, which means now we're having propene. Here, we're having propene because we eliminated, or we were doing what is called cracking. Remember cracking? Thermal cracking. It means you need high temperature to break down. What is cracking? breaking down of large organic molecules into small, most useful ones. So we are able to know, oh, this is cracking. So we are having propene here. We are having a double bond, and you see now we have 1,2 dibromo, which means we are adding Br2 there. So you see this is addition reaction. You have unsaturated becoming saturated, which is addition, and that was cracking, which is part of elimination. So I hope that helps you. If you find a question like this, you can be able to respond. I've already indicated that the main thing here is that you have unsaturated becoming saturated, and we refer to that reaction as addition. You have unsaturated becoming saturated is addition. You have unsaturated becoming saturated is addition. That's all you are looking for. Unsaturated is becoming saturated, that is addition. So you're able to know. Then we'll ask you what type of addition. That's what is important. What have we added? If we have added hydrogen, we'll call it hydrogenation. If we have added a bromine, we'll say halogenation. If we have added a hydrogen and a halogen, we'll call it hydrohalogenation. If we have added water, we'll call it hydration. Now, it's very much important, learners, because for hydrogen, we said it's hydrogenation. And if we say structural formula, you must show the bond between H and H. That is how you write H2 in a structural formula. So that is what you have to understand. And we'll say, what are the reaction conditions? Is there any catalyst that we use? So we're saying when you add hydrogen or during hydrogenation, the catalyst is platinum, palladium, or nickel. You don't have to write all the three, just write one. When you say what is the catalyst, you can just say platinum. We are fine. And then we go to the second reaction, which is halogenation. Say, if I call it bromination, because I'm adding bromine, is that correct? Yes, you can call it bromination. It's fine because you have added bromine, because when you add hydrogen, we said hydrogenation. Now you have Br2 there. Oh, Br2. Is there any catalyst or any reaction condition? No, which means this is a spontaneous reaction. It happens because it wants to happen. You don't have to add anything for it to happen. So this is one reaction that has no condition that is available. All the other addition reactions, because we do 4 addition reactions, they have reaction conditions. Now this one, which is your hydrohalogenation, we're saying no water must be present. So there are places that you don't go with anyone. No water must be present. So that's what we are saying there. No, if water is present, water, it will add itself on the double bond. So we are saying for this hydrohalogenation, no water must be present. And for hydration, we are saying, remember, when there is water, sulfuric acid want to be there. So it's important that you have, when you see water, you think about sulfuric acid as one of the catalyst or of the reaction condition, with exception of substitution, because in substitution we using mild heat there when we're using the water during a hydrolysis, which is what we are going to do. Now when it comes to elimination, we only do 3 elimination, which in this case we are having 1, we're forming 2. You can see we're having now unsaturated, we're having saturated, single bonds only, saturated is forming unsaturated, we call it elimination. We're having saturated forming unsaturated, we call it elimination. We're having saturated forming unsaturated, we're having elimination. You can see that we don't eliminate the bromine. There is no debromination or dehalogenation in this elimination reaction. So that was a spontaneous reaction where we didn't use any reaction condition. We're saying we don't eliminate in terms of our syllabus. There's no elimination where we're eliminating bromine there. Now, so you are able to identify the reaction, and you must know the reaction condition. Remember I told you that cracking is part of elimination. And then we have that dehydrohalogenation, where we are removing a hydrogen and a bromine. This one is very much important for you to understand, because we form 3 products. You can see the other ones were forming 2 products. But for dehydrohalogenation, because we are using now your strong base, your sodium hydroxide there, and AOH, concentrated. Elimination, we use concentrated. Remember when I started, there was USA SU-SSS and CEDS. That CEDS then for concentrated is for elimination, dilute is for substitution. So you are able to do that with no problem. Now you see that here we use concentrated. You can see we use concentrated strong base here, which is can be sodium hydroxide. What happens is that now we're going to Na will take out the bromide, and the OH will take out the H, and they form water. That's how we eliminate it. Remember, you will remove the bromine from this one, and then you will remove the hydrogen from the poorest carbon. So the poorest carbon in this case is this one. You can't remove from this one the hydrogen because it has 3. You will go now saying the poor becomes poorer in terms of elimination. So we eliminate from this carbon because it has 2. I can't eliminate. If I eliminate there, I will have what is referred to as a minor product, but I'm referring to the major product that will form is when we eliminate the hydrogen from the carbon with less number of hydrogens. I hope you get that. Hence our double bond will be there, and we have 3 products. So remember, the hydrohalogenation is important. We have 3 products, and it's a question that has been asked many times. So look at it. And then we are having dehydration, where we are removing water, and then we are able to remove the OH, and the hydrogen we must remove from the poorest carbon, the carbon with less number of hydrogen. That's where we'll do the elimination. Hence the double bond will come there and will form water. You can write water in structural formulas, because the question, if the question say write structural formula, you must be able to write a structural formula. So I hope you have understood those reactions. And our last reaction now, cracking, I talked about it. Remember, cracking, it forms 2 products. It's either will form an alkane and an alkene, like you have seen in the question that we did, or it will form an alkene and hydrogen. Please remember, it is still cracking, which is said it's a chemical process in which longer chain hydrocarbon molecules are broken down to shorter, more useful molecules. So no cracking as well is important. Now, substitution. Under substitution, we are saying saturated becoming saturated. You can see single bonds only there between carbon atoms. Don't be confused by the C double bond O. I'm referring to the single bond between carbon atoms, because that is saturated. We said it's no multiple bonds between carbon atoms. So this is saturated. So we say this reaction is substitution. What type of substitution? Halogenation, because we are substituting a hydrogen. We're removing this hydrogen, we're putting a bromine, hence we call it halogenation. And the reaction condition is sunlight. Then this haloalkane that is formed, it undergoes 2 types of hydrolysis. So there are 2 types of hydrolysis where we use water and mild heat, and dilute sodium. Remember, we said for substitution we use dilute sodium hydroxide, not concentrated we use it for elimination. Dilute sodium hydroxide and mild heat. Our heat is mild as far as these 2 hydrolyses are concerned. Please know this hydrolysis, we can use water, we can use dilute strong base, which is our sodium hydroxide or potassium hydroxide. In that way, then you are able to form your alcohol. The reaction is called hydrolysis, and then we're able again to introduce the Br again, then that will be halogenation. So that is substitution. How do you see it? Saturated remains saturated. As I close this one, I'm able to say we have different reactions, which we refer to as combustion. In terms of combustion, we use them in the, I think you know, the Bunsen burners that we are using at the laboratories. They have propane there, and then you are able to say, okay, when you're having propane and oxygen and reacting with, so you are having an alkane reacting with oxygen to form carbon dioxide and water plus NH. So this is an exothermic reaction. The main thing, you must be able to balance the reaction for the 3rd mark. Remember, the first mark is for writing the reactants correctly, the second mark for writing the products correctly, and the last mark is for balancing the reactions. Then you are able to get that. We can do combustion of butane, which is your lighters, that you know, those lighters, and then you use that, then you are able to balance the reaction. Now, as I close this equation, I just felt this is important. Remember, all we are looking at is this is unsaturated. This is saturated, so the reaction will be called addition. I just wanted to show you the USA SU triple S, how you use it. Every arrow that comes from unsaturated, it becomes saturated. So you know that unsaturated will form saturated product as far as our syllabus is concerned. And then we are saying that now any reaction that forms saturated becoming unsaturated, that is elimination. So you know that the reactions that are going from saturated to unsaturated is elimination. From unsaturated to saturated is addition. So you are able to do that. Then we can ask what type of addition. In this case, you'll say hydrogenation. What type of a catalyst or reaction condition? We said platinum, palladium, or nickel. The same for all the reactions. You are able to say, okay, this one we said is unsaturated forming saturated is addition. We're forming water. We're forming alcohol, meaning that we have used H2O. We have added water. It is hydration. And I said where we have H2O, the catalyst will be sulfuric acid. So you're able to know the reaction condition. Saturated, now for number E, saturated forming saturated, you know that is substitution. Number F, saturated forming saturated, that is substitution. Then you just check what type of substitution and the reaction condition as we have done in the previous slide. So I'm hoping this will help you as you prepare, so that you check USA unsaturated forming saturated is addition, and then saturated forming unsaturated is elimination, and saturated remaining saturated is substitution. I hope you got that correct. As we move now to the rates of reactions. Under rates of reaction, the most important thing, first thing, is how you define the rate of reaction. The rate of reaction. Remember, we're saying this is the change in concentration of reactants or products per unit time. And then you write it in full. Change in concentration of reactants or products per unit time, or changing or the rate of change in concentration of products or reactants. The rate of change. You can't use rate and per unit time on the same statement, because your definition will be wrong. You must be able to calculate the rate of reaction. You must be able to list the factors that affect the rates of reaction. Remember here, sometimes I just use accident like that, so that you remember. Remember, we're saying this is your concentration, your catalyst, your state of division, your nature of reactants, your temperature, and I always say this can happen when you are under pressure. So pressure is important, is a factor that affects the rate of reaction. And we must be able to use collision theory to explain how these factors affect the rate of reaction. We must be able to interpret data. Our data, as we did with question 4, can be tables. Question 3 can be tables or graphs. So you must be able to deal with both tables and graphs. You must be able to define positive catalyst. Remember, we're saying the catalyst speed up the rate of reaction by without it being used in the reaction. And we are saying that how does it do that? It lowers the activation energy. It lowers the activation energy. And we are saying you must be able to interpret the graphs of Maxwell-Boltzmann distribution curves. So we'll look at those graphs, and then we are moving, and you are able to get that. Now, don't forget that these reactions, if you are having, for example, magnesium reacting with hydrochloric acid, forming magnesium chloride and hydrogen gas there, it's important for you to look at the state of our to look at the state of our reactions. And then you are saying this is magnesium is in solid, and this is hydrochloric acid is in aqueous. And then you have aqueous solution for magnesium chloride and hydrogen as a gas. Why? Because these factors, they affect, remember, solids, we're talking about surface area. So if we were to increase surface area, we'll increase surface area of magnesium. If we were to increase concentration, we'll increase concentration of aqueous solution. If we were to increase pressure, will increase pressure, or decrease pressure affect gases. So you are able to know which factor will affect which one. And the question is saying now, how could we measure the rate of this reaction? So it means we can check now the mass. We can look at the mass, change in mass per unit time, change in mass per unit time, change in mass of magnesium per unit time. We can look at change in concentration of hydrochloric acid per unit time. And we can look at change in concentration of magnesium chloride per unit time. We can look at change in volume. Remember, for a gas, we talk about the volume, change in volume per unit time. So it doesn't matter which one. We're saying you must calculate the rate of reaction. You are able to know which formula will be applicable. And we're saying draw possible graphs. So you must be able to know that for the reactants, we start with mass. If it's mass, it will be having change in mass per unit time there. And then you are able to see that our mass will be decreasing because the reactant decreases. But for the products, it does what happens? It increases. So the graph, you're expecting it to go up. And we're saying when our graph becomes straight like that, we're saying now the reactants are used up, or the limiting reagent has been used up. So it's very much important that you have that understanding, and then you understand the graphs. For reactants is that one that is decreasing, for products is that one that is increasing. So I would like to take just a 2 minutes break, and then we come and finish the last part of our session. I'm hoping that we are moving together. Thank you very much. Thank you. Welcome back. Now we're going to look at the collision theory now, to say, for collision theory, we're saying this theory states that there are three conditions for a reaction. We're saying the reacting particles must collide effectively with one another, and the reacting substance must have enough energy, and we're saying they must have correct orientation. So we're saying they must have enough energy, and they must have correct orientation, and then that will be able to help us in terms of our questioning. And then we are saying now, when it comes to the Boltzmann distribution curve, the Maxwell-Boltzmann distribution curve, please understand this one, that if we increase temperature, we are saying that now, as we increase temperature, we are saying that now the graphs there, they touch. So you see, when those graphs touches, you know that we are increasing temperature. So how do I use collision theory to explain what is happening here? Here you must listen and get me correctly, so that we don't lose marks. Remember, when you increase temperature, you are saying when we increase temperature, we're increasing the average kinetic energy of particles. That is the first bullet. When you increase temperature, you increase the average kinetic energy of the particles. And then when you have done that, we are saying that now now you are going to have more effective collision per unit time. Please write it in full. So it's more effective collision per unit time. That is bullet number 2. It's a 6-letter word. If you say effective collision per unit time, we'll take one, it won't mark it. It must say more effective collision per unit time. I'm emphasizing it. And we're saying now you'll increase the rate of reaction. So you see those 3 bullets now, they are very much important. You can say, if you have more than 3 marks, you can as well say more particles will have energy greater or equals to activation energy, which is this statement here. More particles will have energy greater or equals to activation energy. So those are the bullets, and how you will follow them as you deal with this question. So when you increase temperature, the graph, how do you see? The graph touches. We move to concentration. How do you see for the concentration? The graph doesn't touch, it's on top of that other graph. So you are able to see that, okay, when you increase concentration, remember concentration is N over V. So when you increase concentration, you are increasing the number, bullet number 1, you are increasing the number of particles per unit volume. You increase the number of particles per unit volume. That is bullet number 1. You are increasing the number of particles per unit volume. And then we are saying now, as you do that, you will have more effective collision per unit time. And then we are saying you will increase the rate of reaction. So the order is the same. The only bullet that we are changing is that one. When you are dealing with now concentration, you change the first bullet. The other bullets will remain the same. Now we go to catalyst. When you add a catalyst, what are you doing? You are when you add a catalyst, you are speeding up the rate of reaction. It means now you are lowering you are now providing an alternate pathway. So you are giving us another road to move with, providing an alternate road or pathway of lower activation energy, That is bullet number 1. Bullet number 2, more effective collision per unit time. And bullet number 3, increase in the rate of reaction. Bullet number 4, we said more effective, more particles will have energy greater or equals to the activation energy, as we did with the others. So we're saying you change the first one. Don't forget, for catalyst, we're saying you are providing an alternate pathway of lower activation energy. Then you always say more effective collision per unit time, and you increase the rate of the reaction. Hoping that will help you. Now, with no wasting of time, I will move to chemical equilibrium as we wrap up. And then we are saying for chemical equilibrium, the first thing is to know the definition of what is this chemical equilibrium. Remember, the exam guideline is saying it's a dynamic equilibrium. It's a dynamic equilibrium when the rate of forward reaction is equal to the rate of reverse reaction. Please, learners, the main thing there is the rate of forward reaction is equal to the rate of reverse reaction. So it's a dynamic equilibrium where rate of forward reaction is equal to the rate of reverse reaction. You cannot go to write exam without knowing that definition. The factors affecting chemical equilibrium, we're saying Cape Town. The factors we're saying is concentration, is pressure, and temperature. Remember, as you increase concentration, remember concentration, we talk about concentration of aqueous solution and concentration of a gas. So this is much important, my learners, for you to remember to say when you talk about concentration, we're talking about aqueous solution and gas, because we're saying the concentration of solids and liquid remain the same. That's why when you're doing the Kc expression there, for the concentration of the solid and liquid, you just write a 1 because you're saying they remain constant. So you cannot be changing the concentration of the solid and liquid. We talk of the concentration of aqueous solution and concentration of the gases. Hence, we include them on the Kc expression. Now, the other thing which is of paramount importance is that we talk to Le Chatelier's principle, where we are saying when the condition of a system at equilibrium are disturbed, a reaction will take place that will cancel the effect of the disturbance. So we are going to cancel the system itself will now establish a new equilibrium by cancelling the effect of that particular disturbance. So we are saying the important definition: chemical equilibrium, state Le Chatelier's principle, and we are saying the factors that affect your concentration, pressure, and temperature. And you are saying you have your equilibrium constant. For equilibrium constant, the only factor affecting Kc, guys, is temperature. And we are saying for Kc, we are focusing on aqueous solution and gases, which are the two that I said. We talk about the concentration of aqueous solution and gases. I hope you got that and were able to move. And we're saying all definitions should be taken from exam guideline. And we're saying avoid omitting keywords from the definitions. And we're saying the definitions that you must remember: your open system, which you said is the system now that interacts with its surrounding. But this one, the closed one, we are saying now is isolated from its surrounding. The reversible reaction, the chemical equilibrium, the homogeneous and heterogeneous equilibrium, and stating of Le Chatelier's principle. We're saying these definitions we must write knowing them. And you must make sure that you know the endothermic and exothermic reaction. Remember, learners, we are saying if forward reaction is exothermic, reverse reaction is endothermic. Taken from the graph, if I'm to indicate, to say, okay, if you are having a graph like that, forward reaction is endothermic, but the reverse will be exothermic in one direction, as long as the reaction is reversible. And we are saying work out through the examples first so that you are comfortable with questions and answers. So we are saying now, don't go and look at the memo as you are practicing. Do deal with the questions, calculate Kc, go and check after and mark yourself and see where you are making your mistakes, because our question papers, they have memorandums, and our memorandums, they are able to help you. Now, I wanted to use this to emphasize the definition. Remember, we're saying the rate of reaction. What is the rate of reaction? We said the rate of forward reaction. Maybe I must use this one. The rate of forward reaction is equals the rate of reverse, hence they become one there. So that is equilibrium. The rate of forward reaction is equals the rate of reverse reaction. And when it comes now to this other definition, we're saying the concentration of the reactants and the concentration of the product remain the same. It is still equilibrium, that one, because the concentration of the reactants and the concentration of the products remain, not that they are equal, but they remain the same. So I hope that helps you as you prepare for your papers. And then time willing, I wanted to do this one. But what is important is that we can give you, here we're given ammonium chloride, which is solid, and then it's forming ammonia gas and hydrochloric acid gas. So you are able to know that for Kc expression, Kc is the concentration, the ratio of the concentration of the product to the ratio of reactants of only aqueous solution and gases. So when I write Kc, I'm going to write NH3, concentration of NH3 multiplied by concentration of HCl. Why, sir? Because we said the concentration of a solid and liquid remain the same, which is 1. So over 1 is the same as that. So our Kc expression will be that, meaning that you already have a 1 mark in your head already. Now, what is the meaning of the double R? Sometimes we'll say define. Sometimes we'll say, what is the meaning of the double R? You know, it shows that the reaction is reversible. But in this case, we're given the mass of ammonium chloride initially. Remember, we said it will decrease. So you can see that ammonium chloride was 10.7 grams. But at equilibrium, when the line becomes horizontal, we no longer say the reactants are used up. We say it has reached equilibrium, because this is question 6. So you are able to say at 8.1 grams, we are now at equilibrium. Then you know that equilibrium has been reached. But the main thing here is for you to convert these ones now to number of moles, which indicate the importance of you getting the molar mass of ammonium chloride. So because you know always when you have mass, you must say number of moles is mass of a monomer, so that you're able to get your number of moles of this one. And it has been worked out here nicely. The molar mass of ammonium chloride is 53.5. So initially we had 10.7 divided by 53.5, which is the molar mass of ammonium chloride. Then you're able to get 0.2. Remember, when you start the graph of the reactants, you saw the graph. The graph of the reactant start from there, it decreases. But of the product start from 0, because initially we didn't have products. Hence we are writing 0 for the two products there. And then they were able now to indicate that at equilibrium, when the line was horizontal, they said it's 8.1, which means we are given the mass. We can calculate the number of moles, mass of a molar mass, which is 0.15. And then we are able now to use those two to say 0.2 minus 0.05 is 0.15. Then you can see that everything is containing. But we got this one, which was 0.2. Then we got this one. Then we're able to get the change. We're able to get the change. And then you know that our change now is your 0.15 minus 0.2. Then that gives you 0.05. And then on the reactant side, it will be negative because it's being used up. On the product, it will be positive. Remember, we're using the mole ratio, which is 1:1:1. That's why when our change will have 0.5, 0.5, and 0.5. I hope it helps you. And then you are able to add there and get the mark for addition. You add on the product, you get that. Now, let's look at the mark. The last mark is on the table, is to divide by the volume. Remember, the volume was 500 cubic centimeter, which is half liter. So you will divide by 0.5. So you have 0.05 divided by 0.5, 0.05 divided by 0.5. That gives us 0.1, 0.1. Now to calculate your Kc, as I indicated, you will write the Kc expression. You won't include the solid because its concentration, we said, remain constant is 1. So you just write 0.1 times 0.1, then it gives you 0.01. Then you are able to get your 8 marks. And we are saying now, if you don't write Kc expression correctly, you will lose 1 mark. So it's important that you write your Kc expression correctly. I hope that helps you. I wanted here to emphasize the importance of the graphs, the graph of equilibrium, so that you are able to know that what is happening at T1, what is happening at T2, what is happening at T3. Now, with time not on our side, I will move to say at T1, you can see that only N2, only this one, it sharply increased. So you can see that N2 sharply increases. Then you can see that now it suggests that there was this is not a change in pressure. It affects the chemical the concentration. This is also not changing temperature because it does not change the concentration of the species, and then therefore the change in T1 is likely to be addition of nitrogen gas. So we're saying nitrogen gas was added. Why? Because it sharply increased there. So what is the change? When you increase N2, we're increasing the concentration of the reactant. According to Le Chatelier's principle, when you increase the concentration of the reactants, then the reaction that will utilize that N2 will be favored, which in this case, the forward reaction will be favored, meaning that NH3 must increase because forward reaction is favored. You can see forward reaction is favored. And we're saying when you increase N2, more H2 now will be used to react with this N2. So this one must decrease. So when N2 increase, H2 decreases, hence the graph goes down there. You are able to see that at T1, we increase the concentration. But now let's look at T2. At T2, as a concentration of chemical species of the reaction have increased instantaneously. So you can see all of them are increasing. So this suggests that pressure on the system, an increase in pressure or the volume has been decreased. Remember the language, when you say decrease in volume, we're saying increase in pressure. So pressure, how do you know pressure? They will all sharply increase or decrease. So as you increase pressure, they all increase. The concentrations will all increase. As you decrease it, the concentration will decrease. But when it comes to number T3, which is your temperature, the last one, you are able to see that, okay, they all now remain the same. Remember when you increase temperature, you are not changing the concentration, so the concentration there will remain the same. Hence we are saying, okay, this must be temperature. And then if you increase temperature, remember we said if forward reaction is exothermic, it means reverse reaction is endothermic. And we say increase in temperature favors endothermic into mendo. Don't forget that. Increase in temperature favors endothermic, decrease in temperature favors exothermic, detomexo. So if we increase temperature, endothermic will be favored, which is the reverse reaction. So we just check which one is increasing. You can see N2 is increasing and H2 is increasing, which means now endothermic reverse is being favored, which means we have increased temperature. So we're able to say this was because of increase in temperature, which is intermendo. So I hope that has helped you when it comes to this type of questions. You will be fine in terms of that. Now let's quickly see acids and bases as we wrap it up. To say for acids and bases, our main focus is to say our acids now, we define them according to Laurie Bronsted. We define them according to Arenas. Remember, Arenas, he said these are acids are substances that produce hydrogen ion. So you can just say these are substances that produce hydrogen ion in aqueous solution. In aqueous solution, they produce hydrogen ion, and the base produce hydroxide ion, hydroxyl ion, OH, hydroxide ion in aqueous solution. So you are able to put it like that, hydroxide ion in aqueous solution. And then Laurie Bronsted was saying an acid is a proton donor, a base is a proton acceptor. Now, remember, Lena, the strength of an acid has nothing to do with it being concentrated or dilute. I don't want you to be confused there. When we say we are having a strong acid, when we're saying we're having a strong acid, it's because it ionizes completely in aqueous solution to form high concentration of hydronium ion. And a strong base, it will dissociate completely in aqueous solution to form high concentration of that one. So it's very much important that you have that understanding. And when it comes to the weak acid, we're saying it ionizes incompletely. It doesn't completely ionize. So it will form low concentration of hydronium ion. And the weak base will dissociate incompletely in aqueous solution to form the low concentration. So the concentration that is formed is low. Hence, strong acid, we are saying they have a Ka value that is greater than 1. They have a high Ka values. And strong base, they have a Kb value, which is the ionization constant of acid, is of strong acid is greater than 1 because it ionizes completely. For base, the ionization constant is less than 1 because is greater than 1 because it dissociates completely. But for the weak acid, it will be less than 1. Ka value for weak acid is less than 1, which means 1 will be greater than Ka. For weak base, Kb value would be less than 1. So you got to understand, when you have a Kb value of less than 1 is for weak acid. When it's greater than 1, for Kb value of less than 1 is for weak base, and Kb value of greater than 1 is for strong acid. So it's important that you understand the meaning of these Ka and Kb values. So I've indicated there for you that the strong acid, these are our common strong acid, is hydrochloric acid, sulfuric acid, and nitric acid. So you must know them. Our common weak acid, we have hydrofluoric acid, phosphoric acid, sulfurous acid, oxalic acid, and ethanoic acid. I've already defined strong acids for you to say they ionize completely in aqueous solution to form high concentration of hydronium ion. We say strong acids has a Ka value greater than 1. So they have a high Ka value. And then we are saying the weak acid, they have a Ka value less than 1. And we are saying all organic acids, the acids that we were doing in organic chemistry, they are all classified as weak acid. The strong ones are those that we have indicated. I've emphasized the issue of the ionization constant of acid and base. And then when it comes to the base, is the same as we define. But what I want you to emphasize here is that the strong acid are the group 1 elements. Group 1 elements, your LINAC, your lithium, sodium, potassium, hydroxide, these ones that we have written here, these are your strong base. And the others are most likely to be weak base unless otherwise stated. So you have to get that one to say these are the strong ones, then the other ones will refer to them as weak unless we have indicated their strength when we're asking those questions. So you are able to get that one correctly. And then on the issue of conjugate acid base pairs, it's important to say an acid on the left, we must have an acid reacting with a base to form conjugate acid and conjugate base. How do you know? So we are saying, if you look here, we're having a conjugate is something that is related to. So what is related to H2O here? Who is a close relative of H2O? That is OH minus. So close relative of H2O is OH minus. The different is the hydrogen ion. So I'll say water is an acid and OH is a conjugate base. So you can see a conjugate base, it says hydrogen, it's running short of a hydrogen ion. And then if you look there, we're having the relatives here will be HSO4 minus and H2SO4. So you're able to see that, okay, the difference in these relatives, this one has more hydrogens ions. It has an extra hydrogen. So you can see that this one must be a conjugate acid and this one must be a base, because on the left we always have an acid and a base. So you're able to see that, and then you just look at the relationship to say, okay, the close relative of SO4 is HSO4 minus, and the one with more hydrogen is your acid. But on the right we have conjugate acid, which means this one will be conjugate base, and the conjugate acid is a relative of a base. And then we are saying base react with an acid. So you are able to see and determine these conjugate acid base pairs. And we're saying a strong acid is a weak conjugate base and a weak acid is a strong conjugate base. Vice versa, a strong base will have a weak conjugate acid and a weak base will have a strong conjugate acid. So you are able to have that and do that. Remember, you are expected to do titration as well. We're saying know all the apparatus that we use for titration. Remember, you have the pipette that you use there to pipette your standard solution. Remember, standard solution, we're saying, is a solution of known concentration. And then you must be able to use an indicator that will show you when we reach the end point. Remember, at the end point, the indicator will change color. And you have the burette there, and you have your conical flask that you are using there. Sometimes we are saying Erlenmeyer flask, and you are able to titrate, which means now in this case you are having an acid on the other one is having a base. Then you have the indicator. When the indicator changes color, you know that we have reached equivalence point, which means all the acid has reacted with the base. And the formula that we use is that formula of CaVa over Cb, Vb equals to Na over Nb. So that is the formula that you will utilize for that type of equation, and you are able to get your marks. And ensure that you substitute as you use this question. Now, when you talk to the issue of pH, we're doing your pH, which is minus log the concentration of H3O plus, the concentration of H3O plus, which now is equivalent to the acid. Remember, we do this for the monoprotic and the diprotic. Let's say you are having ACl. If I say the concentration is 1 times 10 to the power of minus 1, which is 0.1 minus 1. So you are able to put that into the formula as minus log 1 times HO3. The formula, always copy the formula as it appears in the data sheet. pH equals to that. When you are given that concentration, remember, when you have the ACl in water, we said it ionizes completely to form H3O plus and plus Cl minus. So the HO3 plus there, this one, is 1:1. Hence, you take the concentration of ACl, you put it there, you are able to calculate your pH. That will give you 1, and then you are able to get your answer by substitution. But if you are having, for example, H2SO4, which is now a diprotic acid, whatever the concentration, if the concentration is 1 times 10 to the power of minus 1, you must first multiply it by 2, so that you are able to get, because H2SO4 will form 2H3O plus. So it's important that you multiply your concentration by 2 when you have a diprotic acid. And then when it comes to the question where you are given the concentration, say, of sodium hydroxide, which let's say is 0.5, your responsibility there is to use the Kw, or you can say pH equals to minus log concentration of H3O plus, then you use the Kw, which now we are saying minus log. So you can just write Kw, that is 1 times 10 to the power of minus 1 times 10 to the power of minus 14 divided by 0.5. So if you do that, you will be able to get the correct answer. And then as we complete the last question, which is now the last question topic, which is what we refer to as electrochemistry. We are saying know all the definition. Remember, you have done loss of electron is oxidation, gaining of electrons is reduction. You have done an anode as the electrode where oxidation takes place, electrode where oxidation takes place, cathode, electrode where reduction takes place. You have done the reducing agent. So what I usually say, I say loss of electron is oxidation. It's a definition, and that gives you a reducing agent, which is oxidized. And gaining of electrons is reduction. That gives you oxidizing agent, that is reduced. And then you are able to know that, okay, when you say define oxidation, you say loss of electron. Define a reducing agent, you are able to say it's a substance. It's a substance that undergoes oxidation. Define oxidizing agent is a substance that undergoes reduction. So you are able to do these reactions, and you are able to get. Now, under galvanic cell, those are the most important thing. Those are definitions, and then the other important things are as we did and show you in this type of reaction. So you will get your question in this form, where you will check from standard reduction potential table. You will be able to see that, okay, zinc is minus 0.76. That makes it the anode. You remember this smaller one number is, that's where your anode is, and your cathode with a bigger value there, as I summarize, because we are running short of time. Then you know that your cathode is the one that is having the 0.34. So that is your cathode, and then it's a positive 0.34 your cathode, and and your anode negative 0.76 for the anode. Then the anode will lose electrons, and the cathode will gain electrons. And you must know how to write your cell notation. Remember, if you are given a cell notation like this one, you must be able to identify that we are having now Ag plus, which is your oxidizing agent, plus copper. So you are able to see that this one, the Ag plus, is your oxidizing agent. So you can see that copper is going to lose electron to become copper 2 plus. Ag plus will gain electrons to become Ag. So you are able to see which one will be reduced. So your question can be in that form. On this question, it was which one of the following represent the oxidizing agent in the above reaction, and they were saying oxidizing agent is Ag plus. So the other thing, know how to calculate the EMF as well, because you will definitely get questions that will need you to calculate the EMF using this table, and you are able to do that. And then I'm saying know all the definition that pertain to the topic. Let's say on this one, which was magnesium and a hydrogen cell. If I'm just looking at the EMF as I conclude, to say that the EMF of the cell, you copy the formula as it appears on the on the uh on the data sheet. Don't change anything. Just copy it. You'll get 1 mark for that. E cathode minus E anode. You write that and you check your cathode. You will see that hydrogen, it has 0,00 on the table. Magnesium has negative 2,36 if my memory serves me well. So you are able to see that, okay, the one that is a bigger number, that is your cathode, then minus 2,36, then is your anode, and you are able to say the EMF will be 2,36 volts, and you get 4 marks for doing that. So ensure that you are able to do that. The other issue that I want to emphasize is the issue of the cell notation, to say know how to write the cell notation, where we said you are a reducing agent, which in this case is magnesium. Your metals, they are mostly your, if you are having a metal and non-metal, the metal will be your reducing agent. You are able to see that, okay, magnesium will lose electron to form magnesium 2 plus, like that. Then you'll have your hydrogen ions gaining the hydrogens, the electrons to form hydrogen gas. So you're able to see the half fractions. Then you're able to do what we refer to the overall. Remember, for the overall, you just ensure that the electrons are balanced, and if electrons are balanced, you cancel them and you write your reactants, which in this case magnesium plus 2H plus on the left. On the right, you will have your products, which is magnesium 2 plus hydrogen gas. Then you are able to do that, and you are able to do what you call cell notation. For cell notation, we are saying ABC, which means that you will have your anode, your salt bridge, and then your cathode, which in this case, your anode, you are saying magnesium loses electron to form magnesium 2 plus. You see I separate with this line there. You can write the concentration, which is 1 mole per cubic decimeter, and then you indicate the B stand for the salt bridge there. Then you are able to show 2H plus, which is a aqueous solution, and the hydrogen gas, which is now a gas. So you can't connect your electricity to a gas. Hence, you will use platinum. Hence, you must indicate platinum, which is solid in this case. So it's important that you indicate the phases as well. Then you are able to write your cell notation. I hope that will help you. Your very last question is what we refer to as electrolytic cell. In this case, now we are saying there are 4 electrolytic cells that we are doing, and this electrolytic cell, unlike the galvanic cell, this one is non-spontaneous, and is endothermic, which means energy is added. Endothermic. So this one is endothermic and is non-spontaneous. And we are saying you do the decomposition, which is the breaking down of copper chloride. So what you are doing, copper chloride solution, you are having your beaker, you want to break that down, your copper chloride. When you're having carbon and carbon as your electrolyte, you are having positive anode. Now the positive becomes anode and the negative is a cathode. Then you are having your copper chloride there. So what you have to do to decompose, you want to form copper and chlorine, which means that at the anode, now you'll form Cl2. You will form Cl2, and then you are able to see that, okay, you are forming the chlorine gas there, which means now you are having 2Cl minus, losing electron to form chlorine gas plus 2 electrons. And at the cathode, which is now negative, you will have a copper 2 plus, gaining those electrons to form copper. So that's how you go about doing this cell. The other cell that you do under the same of this question is your electrolysis of concentrated sodium chloride. In this case, it is not sodium that gains electrons. It's water that gains electrons. That is very much important. It will still be 2Cl minus, forming Cl2 plus 2 electrons on the anode side. But on the anode is the same reaction, we'll have 2Cl minus. So we are saying as long as you are dealing with electrolytic cell and you have a halogen, it will always be on the anode. It will lose electron, then it will form chlorine gas. On the cathode, we are saying it's not sodium ion that gains the electrons. The electrons will be gained by water, which is 2 water plus 2 electrons will form your now hydrogen gas and your 2H minus. So you're able to do that. So those are the two reactions. And then the next two last reactions that you are doing under this topic will be your refining of copper and electroplating. What you have to understand is that under refining of copper, the most important thing is that now if you are refining copper, it means you are having copper that is impure. On the anode, you have the impure one, and the pure one is on the cathode. So the impure one there, I can say this is your impure copper, and then we're having a pure there. Then what happens? Same, it's like same reaction, because copper on the anode will lose copper solid, will lose electron to form a copper 2 plus 2 electrons. And on the cathode side, you just write the same reaction in reverse, and you will say copper 2 plus 2 electrons forms copper. Remember, on the cathode, we have gaining of electrons that is taking place. So that happens in terms of purification of copper. And electroplating, as your very last process that you are doing on this one, you are going to have the metal on the anode, and the metal will lose electrons. And on the cathode side, you just write the same reaction in reverse. Please do that. You will see that there are a lot of marks that you can get in terms of this particular question. So I hope you were able to understand. I'm saying as I conclude, don't panic. What do I mean? We are saying now positive is anode. Remember, we have been saying negative is anode under a galvanic cell. But under electrolytic cell, we are saying positive is anode and negative is cathode. And then we're saying the halogen will always be on the anode, meaning that for the decomposition of copper chloride and for the electrolysis of sodium chloride, you will always have chlorine gas being formed at the anode. Please don't forget that, and it will help you. And we're saying electroplating, you will always have an object, which in this case is the spoon, and you will have a metal, and it is the metal that loses electrons. And on the spoon side, or on the object side, on the cathode, you just write the reverse reaction. Hence we are saying the concentration of the electrolyte remain the same, because you see it is this He that is losing electrons to form He plus, and we just write the reverse reaction on the cathode side. And then the spoon will be plated with silver, and then I've indicated as well purification of copper. We have the impure one that must lose, copper must lose electrons. You can see it's decreasing in mass because it's losing electrons. And when you go to your pure copper, there is gaining of electrons. Hence you can see that it increases in mass, but the reaction is the same. Hence we are saying the concentration of the electrolyte remains constant, because the rate of oxidation is equal to the rate of reduction. Now, I would like to say to yourself, as I've concluded, anyone who has never made a mistake has never tried anything new. So you will go and practice and ensure that you do this paper 2 and you perform very well. Hoping that all the strategies that we have discussed in this lesson, you have listened and understood, and you got them. Until we meet again, see you next time. Goodbye.